This problem applies Avogadro's number in a conversion. Let's read the problem. Calculate the number of copper atoms in 2.45 moles of copper. So remember, the abbreviation for moles is MOL. So if you write MOL, that means what a mole is, or moles, okay? It represents either, okay? So now, for the purposes of our class, you do not have to memorize the Avogadro's number. You'll be given Avogadro's number as N sub A is equal to 6.022 times 10 to the 23rd. But you'll be responsible for remembering that that is equivalent to 1 mole, okay? So you'll be given the value, but you will not be given the equivalence, okay? So you have to piece that together, that 1 mole is equal to Avogadro's number of atoms, Avogadro's number of ions. It all just depends on whatever it is that's under study at that time. So in this case, we're looking to calculate the number of copper atoms, okay, in 2.45 moles of copper. So if we know that 1 mole is equal to Avogadro's number, we can say that 1 mole of copper atoms is equal to Avogadro's number of atoms. Okay. We'll say 1 mole of copper is equal to 6.022 times 10 to the 23rd atoms of copper. Okay, so now this is our equivalence. Remember, we use an equivalence to make a conversion factor in order to convert between units. So what is this problem asking us? It is asking us to calculate the number of copper atoms in 2.45 moles of copper. This is our given value. Remember, we always start with the given value in the problem. For dimensional analysis, we're going to start here with 2.45 moles of copper. Okay, so we know that that's what we want to start with. Now, in order to convert moles of copper into atoms of copper, what we're going to need to do is apply this equivalence. Now, we don't always have to go through the step of writing out the conversion factors. As long as we recognize that we need to cancel units diagonally, what we can do is put 1 mole of copper on the bottom to cancel moles of copper. And then that leaves us with 6.022 times 10 to the 23rd atoms of copper to go on the top. Now we're going to cancel our units. And then in this calculation, we have an exponent. Okay, so now that our units are properly canceled and we are achieving the desired units of atoms of copper, now we can start our calculation. What I like to tell my students is to always use parentheses in their calculation to ensure that the calculator does the correct order of operations. So you put Avogadro's number in parentheses, okay? Avogadro's number has been placed in parentheses so that we remind ourselves to use that in our calculator. So what I'm going to do, I'm going to do 2.45 times, open parentheses, 6.022 times 10 to the raised to the power 23, close parentheses, equals. Now, in your calculator, you're going to get a particular number of digits, but remember, we're following significant figure rules, which means that we will round to the least number of significant figures in the calculation, because this is multiplication. Okay? So my calculator gives me 1.4 0.7539 times 10 to the 24th. Okay. Okay, that's what my calculator gives me. Now our answer, we need to round to the least number of significant figures. Here we have 1, 2, 3 significant figures. So we're going to round our answer to be 1.48 times 10 to the 24th. And then what's our units? Our units are atoms of copper, or copper atoms. Okay. And then that completes the conversion from moles to atoms using Avogadro's number.